Okay, class. This is part two of the quiz. Let me arrange my papers. All right, and I actually worked out the problems for you. I'll try to remember as I go. Um, this first problem says that we have four call letters for radio stations, and I believe they said the first one had to be a W, and the other three letters were arbitrary. So, how many different call letters are possible of this type? Well, you only have one choice for the first one. It has to be a W, but the other three are completely unrestricted, and because there are 26 letters in the alphabet, you would set up a slot diagram that looks like that. Number 12 said, well, instead of rolling two dice that have six faces, let's say one of them is 20-sided and the other one is four-sided. How many possible outcomes are there? Well, again, you would set up a slot diagram, and it looks like you would have 20 possible outcomes for the first die, 4 for the second. Multiply them together, you get 80 total. Now, I believe number 13 was just a calculator exercise. It said something like, how many ways can you choose 2 out of 6 things if you're assuming that they're permutations? So the answer is just 30. But let's review how to do that with a calculator. Remember, enter the 6 first, and then the permutation symbol, and then the 2, and then enter. That's how you do it on that calculator. So that's how you get 30. Let's do it real fast on the other calculator too. Sorry for the chalk dust. But on this one, you would go to calculate mode, and then menu, and go down to probability, and choose permutations. And it will give you, it looks like something like NPR and then a couple of parentheses. So you just enter 6, 2 in the parentheses. A little hard to see there, but if you do, you'll end up 30 with 30, just like the other calculator. All right. So really just a calculator exercise. So let's try number 14 real fast. All right. Now on this one, I believe it said something like there are 14 swimmers in a race total, and we're going to consider the 6 fastest swimmers in order. How many different ways can the 6 fastest swimmers finish the race? So order matters here because if Fred is first versus second, it makes a difference. It's considered a different possibility, a different permutation. So it would just be 14 choose 6 permutations, and you get this huge number. All right. So that kind of reminds me of the trifecta problem at the racetrack. If they say how many different ways are there to be a trifecta, if you have, say, 10 horses racing, it would just be 10 choose 3 permutations because in a trifecta, you have to consider first place, second place, and third place, but the order matters. And for the horse race, it would be something like 10 choose 3. All right, now number 16 says something like we have 9 flags total, and we're going to select 5 of the 9 flags to form a word. And it's kind of implied that the ordering of the flags makes a difference because if you think of letters, the word cat is different than the word act. So order matters in this case. But you're just choosing 5 out of 9 things, but order matters because we're forming a message. So if you plug that into a calculator, you get 15,120. And I'm going kind of fast, I know, but if you're if you're watching this on YouTube, you know you can pause it or rewind it. 17. I can't remember the exact application, but I remember there were 20 objects total, and we were choosing 3 of them. And I don't think order mattered. So I'm not sure if this was a committee problem or what, but it was just another kind of basic combinations problem. So I guess I won't spend very much time on it. Now, 18, I don't remember the exact wording, but it said something like 6 men work at a company, 12 women work at a company, and we want to select 3 of the 6 men and 3 of the 12 women to attend a conference. How many different ways can we do that? Well, just break the problem up into 2 parts. 6 choose 3 combinations is the number of ways to select the men because you have 6 total and you're selecting 3 of them. But because they're all going on a committee, they all have the same job. So the order of selection does not matter. And the same logic applies to part 2 of that problem. You have 12 women total, you're selecting 3. So 12 choose 3 combinations, and you have to multiply those two numbers together. If you plug it into a calculator, the first one is 20, the second one is 220, so 4,400 is your answer. Okay. And on 19, on my quiz, and I'll try to paraphrase as well as I can, but essentially we're trying to form a committee in this problem. And I believe there were, I guess I might just make up something, say eight people on an advisory board, and we want to select 4 of the 8. We might have 5 students, and we want to select 3 of the 5 students. And we might have 10 police officers, and we want to select 3 of the 10 police officers. How many different ways can we do it? Well, we're putting them all on a committee, so the order of selection doesn't matter. That's why I use combinations. So the trickiest part of that problem is really just plugging it into a calculator, but you should get 70 and 10 and 120. All right. And number 20 said, use Pascal's triangle to answer the following question. And it said, you have a set containing one object. How many different ways can you select one object out of the collection of one objects? And the answer is 1. It's kind of a trivial problem, and you can use a calculator to do it. But if you really want to do it the right way, you're supposed to set up a Pascal's triangle. And I went ahead and did that for this problem. So remember, when you sketch Pascal's triangle, you start off with a 1 at the top, and then you put 1s on the outside, and here are the first several rows. So we get the 3 by adding the 2 and the 1. We get the 2 by adding these two 1s together. And if I add 1 and 3, I get a 4 there. If I add 3 and 3, I get a 6, and so on. So just remember, when you use this triangle, you always assume that the first row is row 0, and that's the end. And the R's are the columns, but you want to remember that the columns are are vertical, and they start at 0. So in this particular problem, I'm looking for the element in the first row, first column. Well, here's the first row. That's column 0, so the first column is actually right there. So you can get the 1 that way too if you want to. So I know I did that kind of quick, but remember, you can pause and rewind. So that's part 2 of the test review. And if you're watching this video, I would go ahead and schedule your test sometime this week, because I think our test is scheduled to be on Tuesday after the break, and I think the library and all the proctors are going to be gone during spring break. So it might be a good idea to test or to schedule your test sometime before the week is over, which would be noon on Friday.